So here I want to talk about question number 10 of homework 4. This is what we call a deferred perpetuity case. So similar to deferred annuity, this turns out to be one of the challenging topics of this course. So I want to use this question as an example to show you how to solve this kind of question. So let me first just do the setup. EIS.com Bank just issued some new preferred stock. The issue will pay an annual dividend of $16 in perpetuity, beginning 5 years from now. So we said normally to apply the formula for perpetuity, we have to make sure the first payment starts from next year, but now the first payment starts from 5 years from now. So that means we cannot directly apply the formula for the perpetuity. Um, if the market requires a return of 3% on this investment, how much does a share of preferred stock cost today? So again, the biggest hurdle to solve a question in this course turns out to be how to use the right framework to analyze the question. Or in other words, how to put the numbers into the right place. So based on the instruction here, how much does a share of preferred stock cost today? So that should be asking for the value of the preferred stock, or putting one more precise term, it's asking for the intrinsic value of the preferred stock. Because basically intrinsic value is the fair value or the economic value or the most you would be waiting to pay for the preferred stock. So that's all we understand what the question is asking us. So again, to use the formula for the preferred stock, we know that preferred stock is a perpetuity. So the perpetuity formula, present value of the perpetuity formula applies when the first payment starts from next year. But now the first payment starts from year 5. Uh, so how can we solve this type of question? Just to better show you how to do that, so let me copy this question to my OneNote so I don't have to switch back and forth. Okay, so now so let me draw a chart. As I said, it's always a good idea to draw a chart to help you understand what's going on. So 0, 1, 2, 3, 4, 5. So what happens is first payment is right here at year 5, and that's $16 dividend. And this continue forever, right? Because we have a perpetuity, we have preferred stock, and preferred stock doesn't have a maturity date, so this potentially can continue forever. And given the return, expected return or required return, given the risk of the preferred stock, it's 3%. So that's basically what happened. Um, so it's asking for the present value in terms of the current year. But again, we know the formula for the present value. That's pretty easy. That's the payment, right? In this case is the dividend. So it's D. It's constant dividend divided by the R. But we have to make sure this applies when D starts from next year. Otherwise, we cannot use this formula. But then in this case, obviously it's not the case because the first payment starts from year 5. But now we can solve this question still using that formula, but we have to move our baseline. We have to move our baseline to year 4. When we stand here at year 4 and look forward, now the first payment starts from next year. So then we can solve out the present value in terms of year 4 first. But it's not done because what we need is the present value in terms of the current year, year 0, not year 4. But once we have the present value of year 4, then we can move this back to the true present by 4 years, right? When we move this back, when we move our baseline to the true current year, then this becomes the future value. So when we are essentially discounting this future value by 4 years back to the true present. And then we can solve out the present value of that single cash flow. So basically we have described a way to solve this question by 2 steps. Step 1, get present value in terms of year 4. And this we can use the formula, which is right here. If this formula applies, now the first payment, which is year 5, starts from next year when we stand at year 4. So this equals $16 dividend divided by 3%, which gives us 533.33. I just did the calculation with my calculator just to save some time. So again, we are not done yet. We just calculated basically the present value in terms of year 4. But what we need is right here. So then we have to use another step. Step 2, get the true present. So that's in terms of year 0. But again, once we have this present value in terms of year 4, the true present value relative to that year 4, relatively speaking, present value in terms of year 4 becomes the future value. So we can use the present value formula for a single future value to figure out the true present value. So that's year 4 times 1 plus the interest rate, which is the discount rate here, 3%, raised to the power of, again, we are calculating the present value, and we have 4 years between the current date and year 4. So the power here should be a negative number, -4. So just plug in numbers. 533.33 times 1 1.03 raised to the power of 4 equals, I just did the calculation in my calculator. This turns out to be 473. So the question asks me to give me 2 decimal places. So this means it's 0.86. So let me put back this number. This is number we need now. This is number for the present value in terms of the true current year. So 473.86. And then we can check the number, check my work. So good. So we did a We did get the right answer. So again, for this type of question, we just need to move our baseline uh, to the year right before the starting year of the dividend for the perpetuity problem. Then we can apply that formula. And once we have the present value in terms of the year, which is the 1 year before the starting year of the dividend, then we can further discount that present value back to the true present by using the formula for the present value of a single future cash flow. So that's the discussion for this question.